In this video lecture, I'm going to explain about the k-dimensional trees. It is invented by the John Lewis Bentley in around 1970s. In particular, it is 1975. K-trees are also known as the k-dimensional trees, where k represents the number of dimensions. It is a binary search tree where data at each node is a k-dimensional space, a point in a space. Usually, we use it as 2 dimensions, 3 dimensions, 4 dimensions, etc. K dimensions, where k is the number of dimensions. Main idea of this KD trees is like at each level of the tree, we will be comparing it with against one of the dimension. It may be x or y, or it depends on the number of dimensions. If we have two children at each node, instead of the second, we will be comparing with the first dimension. It, Here's a small introduction to the k-dimensional trees. The points to the left of the space are represented by the left subtree of the node, and to the right are represented by the right subtree of that particular node. In this video lecture, I am going to explain on the concept how the space is divided and how the trees are formed. The root will be aligned with the x plane, and the root's children are aligned with the y plane, and the root's grandchildren are aligned with the x planes, and the great grandchildren with the y planes, and so on. Here is an example of inserting the numbers into the k-dimensional tree. Let us have a look at this example. There is 30, 40, 5, 25, 10, 12, 70, 70, 50, 30, 35, 45. 30 and 40 be the root node, and this is x, this is x, this is y, this is x, this is y. If we have more nodes, and it would be xy, 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 and so on, depending on the number of nodes we have in the tree. 30, 40 is the root node here. When we have to compare with the x coordinates. So when we compare the 5 with 30, 5 is less than 30. So it comes onto the left side of the subtree of the particular node. And when we compare the 10 with 30, 10 is also smaller than 30. So it also comes on to the left side of the left subtree. But here we have to compare y coordinates, that is 12 with 25. 12 is lesser than 25. So it comes on to the left side of this particular node. So after this, it's 70, 70. 70 is greater than 30, so it comes onto the right side. And 50, 30. 50 is greater than 30, so it comes onto the right subtree. But here, you have to compare it with the y coordinate of this. So 70 is greater than 30, so it comes onto the left side of this particular node. When we compare 35 with 30, it's greater, so it comes under the right subtree. But when we compare with the x coordinate of this particular node, that is 35 and 50, 35 is smaller than 50, so it comes on the left subnode. And this is the two-dimensional representation of the given example. And here is one more example, inserting these pairs into the k-dimensional trees. As we've seen before, let us take this as the parent node. And 40, 45. And 15 comes 70. 15, when we have to compare the x coordinate. So 15 is lesser than 40, so it comes onto the left subtree. And 70 come at 10. 70 is greater than 40, so it comes onto the right subtree. And 65 comma 50. 65 is greater than 40, so it comes onto the right subtree. Here we have to check with the y coordinate. So y coordinate is 50. So 50 is greater than 10, so it comes under the right subtree, right of this particular node. And now 66 comma 85. 66 is obviously greater than 40, so it comes under the right side. And when we compare 85 with the 50, here we have to compare x. So 66 and 69. So 66 is lesser than 69, so it comes onto the left side of the right subtree. And when to the last one, 85, 85 is greater than 40, so it comes under the right subtree. And we have to compare the 90 with the, no, we have to compare this 90 with the 80, no, 85. Here we have to compare the x coordinates. So 85 with 69. So 85 is greater than 69, so it comes under the right side of this particular node. And this is the two-dimensional representation of this example. And that's it.